Okay, specification. So I'm gonna go through what I've written so far. So I've kind of started on the spec here. But yeah, just in general, like I'm kind of I fear that this is kind of like the dull phase of the project where there's just like a lot of grind work and it's not going to be like a lot of fancy apps and cool stuff. Like this all got existed to kind of inform us to get things sort of on screen and teach us exactly what the project is and isn't and kind of how it shapes. So yeah, this has been a great lesson for the last almost year now. I think in June or July we're coming up on a year, so that's all been good. And yeah, the code exists. And yeah, we have all the demos and stuff. But yeah, the goal here is to now get this specified, get some formal specification down to at least describe exactly what it is and isn't, and then to inform if somebody's going to start an implementation in a new language, they have something to work off of, and that if there's any ambiguity or whatever, at least we have these documents to sort of decide how it should be and get that written down. So the first thing I did starting this, so yeah, Moneysocket RFC is the repo. So I wrote this shortcomings document because this is sort of my collection. As I've been building stuff, this is sort of my collection of things that I think that are missing or like could be better. So things that I haven't fixed in code that are kind of like a little more sort of conceptual shortcomings. So I think the code is like 80% there, but yeah, there's like a lot of like kind of missing features that would really make it good. So yeah, I kind of classified these as like big, medium, small, and then there's sort of some pie in the sky things that we can also talk about. So the goal here is to specify not the code as it exists here for the demos, but like specify that plus kind of fix all the things that should be there in the spec, and then we kind of then circle back to go modify the libraries to adhere to that. So that's kind of the working plan here. So I don't like this would be a lot to kind of describe, and it kind of gets into the details, and that's probably too long for this video here. But yeah, this is just a good way to get it on paper, and I might even add things, and then as I'm working, I can kind of circle back and as I'm addressing things, and then think, all right, well, this problem says X. We wrote the spec as Y. Does that really solve the problem, or do we need to think more about that? Is this as big of a problem as I thought it was? So yeah, that's good. And yeah, like I numbered these things so we can discuss them. And yeah, this isn't like super well grammar written and all that. So there's probably some typos and whatever else in here. So in the actual spec, so I wrote 4 documents here. So I'm calling these basis of Moneysocket to kind of ape what Bolt, the basis of Lightning technology. So and it's kind of the same thing. Like there'll be like a collection of I don't know when this is finished, maybe a dozen ish documents that kind of describe it all. Like these Bolt documents, these get pretty. There's a lot of complexity hidden in some of these. So after reviewing all this and comparing it to what I've written it for Moneysocket, I think overall this is like a less complex proposal. I think these articles are going to be a little bit shorter, a little more concise, because yeah, I don't think the scope is as big as what Lightning is, where it has to deal with on-chain stuff in a peer-to-peer network and messaging and onion routing and all these other things. I think yeah, this boils down. So the first one is just an introduction. I just kind of this is where like you put together a glossary. I haven't actually defined all these terms yet, but yeah, that's certainly something I can do as a sort of a later iteration. So one thing that I've thought quite a lot, and I've talked to people like Fiat Jaff and kind of thought about what a good way to roll out the versioning is, and I think I've kind of gone from a position where we need to be pretty strict about this to kind of just admitting that strictness is probably impossible, and that you should probably minimize the amount of versioning and enforcing things based on versioning. So it gets down to having a really good core piece of the protocol where, like, to say you talk money socket, you at least need to do these like minimal things like pay an invoice, request an invoice, all these other things. But as time goes on, people are going to want to experiment and tinker and add additions. We've seen this with Lightning. We've seen this with Bitcoin, for example. With all the BIPs that have been proposed. You know, yeah, just kind of having like a base kind of set of things, and then being very liberal about what can get added and what needs permission. And then it's just kind of making it so like every implementation kind of can opt in. So there's the basic stuff and then the more complex stuff, and then it can be kind of a grab bag of stuff. So in some of the design, I've added some affordances for adding extensions, to have abilities to add non-standard data into the messages, and flag that non-standard features are supported, and just let people do that if they want to, and then just see how it goes, and it doesn't like break the compatibility of existing stuff. And then yeah, hopefully if it's good stuff and it makes sense to incorporate in the protocol, we do that. We add it to the documentation or all that. At least we'll cross that bridge when we come there, or get there. But anyways, yeah. Right now in the existing implementation, version 0 has been what I've been using. So the idea is once the specification is done, it's only done once we have the matching code, and that code will be released as version 1. And then as we patch it and all that, it'll be 1.1.3 or 1.2 point whatever. So that'll be under sort of the version 1 heading. Now, it's possible that this might be the only version ever of Moneysocket. There's no need to sort of do a major revision. However, I've kind of at least defined that there could in the future, if there's need for like a radical kind of structural change, we could go to version 2 where there's kind of like a slightly different approach. So one thing I kind of liken that to, and I have words there, like Python 2 versus Python 3, where these kind of coexist for a time where, this thing, there's known problems with it, but there's maybe some people that rely on it that want to stick with Python 2. But then Python 3 is sort of like a major revision on top of it, and kind of rethinks a few of the fundamentals of the specification. So that's kind of the what I think a good reason to increment these versions would be. So, and that's just being liberal, I think, is the approach. And I have a few more concrete ways that I've encoded that in there, which I'll get to in a second. So BOM, which I have a broken link, O2 encoding, O1 encoding. Yeah, it's just it's a broken link. I'll fix that after. But yeah, encoding primitives. So one thing I'm doing is I'm just borrowing a lot of the encoding primitives, like the TLVs and some of these primitives. These are all defined by Bolt. So in Bolt 1 of Lightning RFC, it defines what a TLV is. There's a pretty important type called a big size that has good reasons for being done in a certain way. And then also one of the kind of the good things that I like about these TLV formats is you can encode custom ones. So you can do experimental and application-specific messages as TLVs, and a stream of TLVs. And there's kind of rules for there's required TLVs and then optional ones where if your code doesn't want to, it can ignore. So that's what Lightning's doing to build things like the key send and some of the more experimental off specification stuff. So the very basic, when there is need for binary encoding, we're using TLVs for the same reasons Lightning is, and then it can reuse the same libraries. It's actually not that hard. Like I already have implementation for these types, but yeah, it's for somebody to write a new Moneysocket implementation in say C or some Rust or whatever, to actually implement these shouldn't be hard, and there's probably already libraries that exist. Of course, C would for C Lightning and Rust for Rust Lightning, but pick a weirder language, Ruby or something. Wouldn't be hard to do this. And then yeah, you have the test vectors of this guy. Okay, so then yeah, borrowing some primitives. So like Betch32, that means something that's specified by a BIP. Libsec piece when we're doing signatures, and possibly handshakes. Schnorr signatures. So these are all defined in Bitcoin. So rather than redefining them, we just reference the existing stuff. So the other thing to make extensibility, so we're using JSON objects in the messages, which is perhaps inefficient. However, it's very flexible. So it's it's not clear to me why we need like ultra efficiency yet. Maybe down the road, rather than coding things in JSON, we can actually define everything as like super efficient binary encoding. But for now, like kind of the idea is that a JSON field is easy to add an extension field. So if you have some feature and you want to append data to it that piggybacks on existing messages, that's easy to just add a new JSON thing, and then clients that don't understand it can just drop it. So yeah, JSON, UTF. So when we need to format text into binaries, UTF-8 is a good thing. And then yeah, UUIDs. So the Moneysocket uses these to some extent, and that's a standard. So those are things that we're referencing, and then I think maybe in the same way that Bolt 1 defines some convenience types for where is it here? TLV. Yeah, there's like signature and SHA-256 and channel ID. There's kind of like some protocol specific things. There's kind of a standardized way to encode them. I think here we can have similar things. So that's bomb number one. Encoding. Okay, so the beacon format. So this is what gets put into a QR code or the string. So I've kind of specified this out. So what's here is just slightly more complicated than what I've got in the existing implementation. This guy right here. So I've kind of added a few more fields to we've discussed sort of this socket versus prongs kind of problem, where if you have a female and a male type ends of the protocol, to connect them the right way. I added a few fields into this. So like a role hint, for example, to say like, okay, this is generated by provider, it's looking for a consumer, or it's bidirectional. So that's sort of one TLV that's encoded into the beacon. Also indicating the version. So at the very least, like if there is a problem, at least the beacon kind of advertises what version that's on the other end that's listening. So that's kind of optional. Shared seed, yeah, so that's a pretty important part, the shared seed. So that's a TLV. That's a low and high value of 64 bits. You get a 128-bit value. And then, yeah, location lists. So in the same way that this has lists of locations, it's the same thing. I think I twiddle around. I twiddle around some of the parameters. How to indicate preference. So if there's two WebSocket locations, one that's through the relay in the cloud, and then one that's through the local network. So the idea is you'd prefer that they connect over the local network because that's like a low latency connection. However, if that's not available at a lower preference, specify the one in the cloud. So that's one way that sort of the beacon can encode that. And then, yeah, like I added the path. So like when you're connecting to a WebSocket URL, one thing these beacons didn't have is like the idea of to connect to a path. Apparently that's part of the WebSocket protocol. So yeah, including that there. So yeah, just a slightly more improved version of this. And then I have for the Betch32 encoding sort of the human readable prefix. So I have Moneysocket at the front of the string. I've kind of, we talked about this a little bit in the Telegram, but the idea of like you might want to have the application be able to indicate some instruction to say, all right, here's a string, you're supposed to paste it in this other application. So whoever's implementing an app could optionally include an additional bit of human readable data that tells the user what to do with that string. So I made that fairly flexible, so it's like it must start with Moneysocket, but then optionally you can add additional stuff, and there's not a ton of restrictions. You can go up to 83, which is something that Betch32 specifies. So that's at least something to start playing with those concepts. Certainly, this is subject to revision if we decide that's a bad idea. So that's the beacon encoding. Provider info. So right now, this is the info. This is like an object that gets passed around by Moneysocket that tells the balance, and then also like in the wallet, whether paying or sending or receiving payments are allowed, and that kind of thing. So I kind of laid out all the rules for those for first the WAD object, which is a quantity of value. So here's some examples. So like if you just have a Bitcoin amount, here's what it is. But if you have a stable value, to say this is $100, here's the details of the asset. You don't want this to be ambiguous, to be like, like US dollars means something. So like there's an ISO specification for it that's 840. You have to put the dollar sign, you have to put USD. So some of these musts are kind of built around the fact that, if it does have sort of ISO definition of like a euro or a Canadian dollar or something like that, you have to kind of specify fairly exactly that's what the currency you're talking about. But then also being flexible to be like make up your own with its own symbol, like a cucumber. Here's 55 cucumbers and that kind of thing. So that's a WAD. That's an important part of the provider info. But the rest of the provider info kind of tells you about what API services are available from that provider. So I define all the rules, but here's an example. So the WAD is an important piece of it. So this is just a basic Bitcoin, but it could have cucumbers filled in there. And the idea that this provider is connected to an account, and that account has a UUID, whether it's allowed to be a payer or a payee. And then extension features. So like if you're adding API, basic. I'll have one example that I'll go into later. This is getting a bit long, so I got to wrap this up, but. I'll be at public keys. So this is sort of the identity stuff that is TBD. This would be put into the provider info such that, the public keys, the fact we can sign or encrypt or all that, and, sort of a friendly name. So this is where some of the extensions go. Messages, these are wire messages. So these have TLVs that kind of in binary kind of describe the basics of what's there. So like the version, what type of message it is, but the big part of it is JSON object. So putting this JSON blob that describes the details of the message, and that includes extension features. So a message is TLVs, has an important TLV, which is the JSON object. So you can have extension TLVs if you want, or you could additionally add stuff into the JSON to kind of add extensions. And I've explained the features and the feature data. So that's messages. Now, so to just illustrate, before I wrap this up, to just illustrate the idea of like extensions. So with the provider info, we had this idea that here's a public key and we can sign or encrypt with this public key, and here's a friendly name for it. So like this is sort of your name, that this is essentially your identity. So you're kind of advertising, there's this public key, but if you're going to display it on the GUI, give it this particular name. So we've talked about, particularly like in the Noster project and, kind of the way SparkShot even works, the idea that you have these public key identities. It'd be really nice if a user could be able to specify what their avatar image is if they want it. And that's sort of important for making, sort of modern social media type stuff. So one thing that might be better proposed as a MIP, because it gets very complicated. That's a fairly complicated problem, but you could do it, to kind of make an extension to the provider info that says, oh yeah, we support this command where you can ask me what my avatar image is, and I will provide it, the image data, either a PNG or an SVG or something that allows you to display. So that's something that I'd consider sort of an addition to the protocol, not part of the core of it. But the way I've defined provider info, among other things, kind of facilitates that. So you could say, yeah, in the features, request avatar, and then I could specify, here's all these different styles of avatar that you could request. And then if they send the request, you provide sort of a binary blob of like the data upstream. So that's kind of a template of how I see it. Now, yeah, I should wrap this up. We're at over 20 minutes. But yeah, need to talk about sort of all the basic handshakes of all these layers. That pretty much fills it out. Like I kind of have to, I think I got to define kind of the semantics of like what this layered architecture is, kind of, for, to inform how the handshakes, the rendezvous, I got to kind of explain what the hell this beacon and relay type stuff is, and how that ties into, kind of how the beacons are constructed. So I have to kind of outline a bunch of that, and then kind of fill in these articles. And then, of course, the hard work of actually implementing this. So that's it. That's anywhere where I'm at. I expect this task to take, a couple months. Kind of the goal is to have this finished with shipped code by the end of the year. That's kind of at least a rough goal. And I think it's doable. But yeah, how much distraction on applications or playing around with other things is also a question. And then, yeah, how hard some of this stuff actually is, particularly if we're talking about some of the cryptography, ephemeral, and all that. So anyways, I'll end it there. 22 minutes. So yeah, thanks for watching and making it to the end.